Okay, so today's lesson is on matrix multiplication. What I need you to do to start is open to page 11 in your packet, pause the video here and try the warm-up, simplify each matrix by multiplying by the scalar, and then state the dimensions of your matrix. All right, so here are the answers. For the top left one, it is 2 rows by 3 columns. So the rows go this way, and the columns are this way. And we write our dimensions as rows by columns. So check all of your matrix entries, all of these values in each matrix. And now today we're going to talk about how to multiply two matrices together. And there's a little song about the process. It's not as easy as the scalar multiplication, but if you write out your work, it is just long, but does not have to be tricky. So when we multiply matrices, like in page 12 here, we've got A times B. When you multiply matrices, the order matters. So what I want you to do first is, what are the dimensions of A and what are the dimensions of B? So for A, you should have said that's a 2 by 3. And for B, that's a 3 by 2. So when you multiply matrices, so for example, A times B, or we can write it this way without the dot, where it's just AB, that's a 2 by 3 times a 3 by 2. In order to multiply, these inner dimensions have to match. If they do, it is possible to multiply the matrix A times the matrix B. And the resulting matrix, the outcome will be a 2 by 2. So let's do that. So I'm going to, over here in the white space, I'm going to write matrix A, matrix B, go get my song. So when we multiply, the result, this one's going to be A times B. We have to multiply row by column. And when I multiply the first row by the first column, I'm going to get the value in the matrix in the first row, first column. And so the song goes like this: row by column, multiply them line by line, add the product, form a matrix, now you're doing it just fine. So row by column, here's my row by column. We're going to add the multiplication. So I'm going to do 1 times 1 plus 2 times 2 plus 3 times 0. And that value is the first entry, the top left corner of our result matrix. So this was multiplying first row, first column. Then we're going to multiply first row, second column. And that's going to give me the value in the first row, second column of the answer matrix. Goes like this. We're going to take the 1 times the 0 plus, I'm running out of colors, the 2 times the 1. So it's the second entry and the second entry here, plus the 3 times the negative 1. Oops, I ran out of room. Now we're going to repeat that 2 more times for the second row, first column, the second column. So now I've got row by column. We have 0 times 1 plus, well, that looks funny the way I wrote that. 0 times 1 plus 1 times 2 plus -1 times 0. And then one more. Second row, second column gives me the entry in the second row, second column. 0 times 0, 1 times 1, -1 times -1. And now let's get our result. Our resulting matrix is, so this is 1, 4, and 0. So 1 plus 4 plus 0 is 5. This is 0, 2, and -3. So 2 plus -3 is -1. 0, 2, and 0 adds to 2. 0, 1, and 1 also adds to 2. So when we multiply matrix A times B, I get the 2 by 2. That's the result I expected. And these are the values. Okay, so let's try to multiply B times A. So B is a 3 by 2. And A is a 2 by 3. So let me check to see if that's even possible. Do these inner dimensions match? They do. That's great. So I can multiply B times A, and I would expect, or I will get, a result that's a 3 by 3 matrix. So I need a bunch of room for that. So if you have space at the bottom, or if you need to find a blank page, I'm going to rewrite out. Now we've got B times A. B comes first. And then A. I'm going to sing for you one more time. Goes like this. Row by column, multiply them line by line. Add the product, form a matrix. Now you're doing it just fine. All right. So we're going to get a 3 by 3. It's going to be a big matrix as an answer. And we have to go row by column. So first row, first column gives me the value in the first row, first column. So if you want to lay out actually the 3 by 3, it's not a bad idea. All right, so here's my 3 by 3. I'm going to have 9 entries, 9 values in the matrix. Okay, so first row, first column, 1 times 1 plus 0 times 0. Now we're going to go first row, second column gives me the value in the first row, second column. And we get 1 times 2 plus 0 times 1. One more. First row, second column. Oh, nope. First row, third column gives me first, oops, wrong color. First row, third column. So we get 1 times 3 plus 0 times -1. All right, 6 more to go. Now I'm going to do second row, first column, 2 times 1, 1 times 0. Second row, second column, 2 times 2 plus 1 times 1. And normally if I was standing at the board, I would show you with my fingers. So maybe let me try this with some arrows. So for the second row, third column, this blank, we're going to go with the first entries. So that's 2 times 3. And then the second part, that's the 1 and the negative 1. So 1 times negative 1, negative 1. Oh no. All right, let's try. These are getting in my way. Okay, let's try the last row, 3 columns. So third row, first column, I've got 0 times 1 is 0. And then negative 1 times 0 is 0. Now we're going to do the second column. 0 times 2 negative 1 times 1. And the third column, 0 times 3 negative 1 times negative 1. Okay, simplify all your entries. This is 1 plus 0, 2 plus 0, 3 plus 0, 2 plus 0, 4 plus 1, 6 plus negative 1, 0 plus 0, 0 plus negative 1, and 0 plus 1. And this was BA. All right, so the question is matrix multiplication commutative? Is AB the same as BA? No, they're not the same. The order matters in which you multiply. All right, so now that you've done 2 with the process, let's go to page 13 and multiply again. So these aren't labeled. Let's start with number 1. It says find A times B. So we've got A. Well, first, let's see if it's even possible. What are the dimensions of A and what are the dimensions of B? So this is a 4 row by 1 column, and this is 1 row by 4 columns. Do these inner dimensions match? Yes. So we will get a 4 by 4 matrix as our answer. Oh, that's going to be large. All right, so A times B. Just rewriting A, rewriting B. All right, let's see if I can fit a 4 by 4 over here. And it goes row by column, multiply them line by line. Add the product, form a matrix. Now you're doing it just fine. So when I do the row by column, there's only one entry each time. So what's negative 2 times 12? That's negative 24. There's nothing to add. The first row, first column is just those two numbers. Now we're going to keep going. And we've got first row, second column. Negative 2 times 5, negative 10. First row, third column. First row, fourth column. So it's nice, this one, we don't have to do any of the adding. All right, pause the video here. See if you can get the other three rows. Got row by column. Row by column. 4 times 6. 4 times 2. And then we've got third row, first column. Third row, second column. Third row, third column. Third row, fourth column. And last, fourth row, first column. Negative 1 times 5. Negative 1 times 6. Negative 1 times 2. Woo! Okay, let's try number 2. It says find A, B. Write out your dimensions. What are the dimensions? Row by column. Can we multiply A times B? If it's in this order, do the inner dimensions match? They do, so we're going to get a 5 by 5 matrix. These just keep getting larger. Okay, we can do it. I believe in us. I'm just going to rewrite my matrices next to each other so I can circle my rows and columns. I might need more room. So if you are a large handwriting person like me, get some extra paper or find some space to do number 2. I'm going to move my number 3 here because a 5 by 5 is just going to be enormous. So give me 1 second. No. Okay, so our 5 by 5. I'm going to have 5 rows, 5 columns. 1, 2, 3, 4, 5. So those are going to be my first row entries. 1, 1, 2, 3, 4, 5. Those are going to be the other rows and columns. I hope I have enough space and I can write small enough. Okay. We've got row by column. I'm going to do 20 times 1 plus 5 times 7. Then we've got first row, second column. 20 times 2 plus 5 times negative 5. And we've got first row, third column. 20, I can't even read that anymore. All right, so then we've got 20 times negative 3. 5 times 4. These little dashes are messing me up. I didn't give myself enough space. All right, then we've got first row, fourth column, 20 times 4, 5 times 3, and then the last column, 20 times -6, and then 5 times 2. All right, keep going. If you need to pause the video to try it yourself, pause the video, or you can work along with me. I've got second row, first column, then we got 1 times -3, 8 times 4, 1 times 4, 8 times 3, 1 times -6, 8 times 2. All right, third row, first column, 3 times 1, 2 times 7. Second column, 3 times 2, 2 times -5. And then third column, 3 times -3, 2 times 4, 3 times 4, 2, 2 times 3, 3 times -6, and 2 times 2. All right, we're getting closer. Fourth row, first column, -2 times 1, 3 times 7. -2 times 2, 3 times -5. -2 times -3, 3 times 4. -2 times 4, 3 times 3. And then -2 times -6, and 3 times 2. Yay, last one, we made it. Fifth row, first column, 11 times 1, 2 times 7. 11 times 2, 2 times -5. 11 times -3, 2 times 4. 11 times 4, 2 times 3. 11 times -6, and then 2 times 2. All right, all the multiplying's done. Now we got to add them up. 20 plus 35. 40 plus -25. Oop, not negative. -60 plus 20. 80 plus 15. -120 plus 10. 1 plus 56. All right, so you keep adding. We got to get all our other entries. Whew. All right, check all your entries. Make sure your values all added up to what I was writing. Actually, let me even check myself with my answer key. Uh-oh. For some reason that entry doesn't. Uh-oh. Uh-oh. Let's see. These are the values that don't match my answer key. So let's see when I made the mistake. So it looks like I have a problem with the second row. Don't tell me I copied the matrix wrong. Okay. Second row, second column. That's 2 and negative 40. That's this. Oh, so that's just an adding mistake. That should be negative 38. All right, let's see what's wrong with the second row, third column. 1 times negative 3, and then 8 times 4 is 32. That one's right. All right, this one's okay. And then the 48. Oh, well, that's silly. I just added, I can see I added wrong. 4 plus 24 is not 48. It's 28. Now that one's good. And then this was the next entry. So that is third row, fourth column. Third row, fourth column. So 3 times 4. Uh-oh. I multiplied that wrong. That's not 8. Were you shouting that at me? Okay. 3 times 4. 2 times 3. So this number should be 18. Ooh, I'm glad I checked. That was some major mistakes there, Miss Weiss. All right, hopefully the next problem is not as long because a 5 by 5 is a bit ridiculous. All right, so the third one. Oh, no. All right, let's see. How many rows here? 2 rows by 1 by 5 columns. And this is 5 rows by 2 columns. Do the inner dimensions match? Yes. So my result should be a 2 by 2. All right, that's not bad. Let's see if I can get it all right and if you can get it all right. All right, here's my matrices. Pause the video and see if you can multiply and get a 2 by 2 matrix. All right, so for our answer, we've got first row, first column. So that's 2 times negative 8 plus negative 4 times negative 6 plus 6 times 4 plus negative 9 times 1 plus 5 times negative 2. All right, this problem is just as ridiculous as the prior one. Then we've got first row, second column, 2 times 7 plus negative 4 times 5 plus 6 times 3 plus negative 9 times 2 plus 5 times negative 9. All right, now second row. Second row, first column, 6 times negative 8 plus negative 7 times negative 6 plus 4 times 4 plus 3 times 1 plus 3 times negative 2. And lastly, second row, second column, 6 times 7 plus negative 7 times 5 plus 4 times 3 plus 3 times 2 plus 3 times negative 9. Whew. All right. Simplifying all these values, our 2 by 2 matrix should be 65, negative 51, 115, and negative 2. That is the final answer. So check your arithmetic. If you want, you could type this entire, this one's pretty long. If you type this in your calculator exactly as it looks, it'll get you 65. If you type all of this in your calculator, it should get you negative 51. You might be saying, but Ms. Weiss, can't the calculator multiply matrices? It can, but tomorrow, or our next class, we're going to have matrix multiplication with variables. And your calculator can't multiply variables. So you need to know the process of multiplying row by column, multiply them line by line. Add the products, form a matrix. Now you're doing it just fine. You got to know the whole process so that when we put variables in the problem and we make them in equations eventually, you know how to multiply them together. All right, your homework, page 14, all the problems. The first set here, not actually multiplying, you're just saying, can you multiply? And if so, what the dimensions would be. And then at the bottom, there's some actual matrices to multiply, nothing as crazy as the 5 by 5s or like that. Don't forget to check your answers in Drive.